Okay, so finishing this guy up, let's get our antiderivatives. The antiderivative, or the integral of cosine, is sine. The antiderivative, or the integral of sine, is minus cosine. Be careful with those SIGNs. Angles do not change, but that 2, the effect of the 2, if I was differentiating, the chain rule would have me multiply by 2. But I'm anti-differentiating, I'm integrating, so instead of multiplying, I do the opposite, and I divide. Evaluated from 0 to pi over 6. On to the next guy, pretty much the same thing. The antiderivative of sine 2x is going to be 1/2 cosine 2x minus sine x, evaluated from pi over 6 to pi over 2. And remember, at this stage right here, both of those parts, those check by differentiation. So you got a few moments, check them. Okay, doing the evaluation. Again, I prefer to work term by term. So working with the sine x, that's sine of pi over 6 minus sine of 0. Plug the pi over 6 into the sine, plug the 0 into the sine. Do them separately. Then that's going to be plus 1/2 cosine of 2 times pi over 6 minus cosine of 2 times 0. And I'm going to drop down because I'm running out of room. And so then this is going to be minus 1/2 cosine of pi over 2 minus cosine of pi over 6, and then minus parentheses sine of pi over 2 minus sine of pi over 6. And then keep going. One advantage to me doing this on video for you, if we were in class, we wouldn't have time in class to do this. In class, I would have stopped right there. But video, I can take as much time as I want. And if you guys don't want to watch it, you can always just turn it off. But that's not the smart decision. I suggest you watch these, especially if you have problems with your trigonometry. Watch them. Anyway, sine of pi over 6 is 1/2. Sine of 0 is 0. Plus 1/2 times, that's going to be, and I'm not going to skip any steps, so that's going to be cosine of pi over 3 minus cosine of 0. And then minus 1/2, so I'm right here. Cosine of pi over 2 is 0. Cosine of pi over 6 is square root of 3 over 2. Then minus parentheses, sine of pi over 2 is 1. Sine of pi over 6 is 1/2. And then keep doing my trig and my arithmetic. So I got a 1/2 there. Don't need that 0. So that's going to be 1/2 times. Cosine of pi over 3 is 1/2. Cosine of 0 is 1. That 0's, you're not going to need that 0. Distribute that minus 1/2. And so that's going to be plus square root of 3 over 4. And then that's going to be 1/2 on the end, so then minus 1/2. Keep going. Minus 1/2 plus 1/2. So I've got 1/2. And so what? I've got 1/2 times negative 1/2 plus 3 square root of 4, which would be negative 1/4 plus, I got that backwards there, don't I? Glad I caught that. Square root of 3 over 4. So that's negative 1 plus square root of 3 over 4 for negative 1 plus square root of 3 over 4. And that is a positive answer, so it's possible to be the answer. If it came out negative, it's not possible. Now, hopefully, I did everything correct here. Again, I'm lecturing to an empty classroom, so if I made a mistake, no one's here to yell at me that I made a mistake. But I feel relatively confident that there's my area. And it is a positive value, so at least I know it's not, I can be sure that I'm not absolutely wrong. Okay, so there's that one involving some trig. Moving on again. Okay, if I look at the last, so here's the next guy. And if I refer back to the previous problem, this took two integrals essentially because top and bottom changed. But it was really obvious to see that top and bottom changed because there was a point of intersection right in the middle of the region. But anytime top and bottom change, you're going to need another integral. Here it was easy to see that we need two integrals. On the next one, it's not as easy to see that this is going to be a multiple integral problem. So here's my region, and square root of x is the top of that sideways parabola. Negative square root of x is the bottom. Let's zoom in just a little bit. So square root of x is the top of that sideways parabola. Negative square root of x is the bottom of that sideways parabola, and then the diagonal line y equal x minus 2. And here's one reason. A lot of people don't draw in the little rectangles. But here's one reason that I did and that I have drawn in the little rectangles is that helps us better visualize top and bottom. If you look at this, there, top and bottom is the sideways parabola. Over here, top and bottom is the upper branch of the sideways parabola, and then the diagonal line. Where things switch, right there. And so it is going to be two integrals. And I need to know that point and that point. Now, I didn't suppress the tick marks, but again, you're not allowed to guess by just looking at it. Now, if I had labeled this point for you, if I very clearly drew the point and labeled the point 1, -1, you could use that information. Same thing over here. If I very clearly labeled the point, and I think it's going to turn out to be 4, 2, if I very clearly labeled the point, then you can use that information. But I didn't clearly label, and so you can't guess. And so I need the points A and B to find A. That is the intersection of the y equal negative square root of x and the y equal x minus 2. And just like before, I'm going to set those functions equal to each other and solve. To find points of intersection, you set the functions equal to each other and solve. So I'm going to set them equal. Best way to solve this guy is to square both sides. And so that's going to be x equal x squared minus 4x plus 4. 0 equals x squared minus 5x plus 4. And that factors, what that factors to x minus 4, x minus 1. So we get x equal 4, x equal 1. Now go look at your graph because we got two answers. So now go look at your graph and pick the one that's appropriate. The one that's appropriate is x equal 1. To find B. It's the intersection of y equals square root of x and y equal x minus 2. So set those equal to each other. And notice we're going to end up with the same equation again. It's just that this time we will pick, let's go out a little bit. We will pick, based on our graph, the appropriate one is 4. So, just going to draw a rough mock-up of my graph again here. And that was A. So I'm just off to the side copying my graph over, and so you just have to wait until I'm done copying the graph. That's x equal 1. This was B. Which is x equal 4. This is y squared of x, y equal negative square root of x, and y equal x minus 2. So there I've just copied the graph again. Not a very pretty graph, but I copied it again. And so we, again, had decided earlier that I was going to need 2 rectangles. We'll call this A1 over here A2. I need 2 regions because in this case the bottom changes. And so my total area will be A1 plus A2. I am fine on that one. Our basic algebraic knowledge should tell us that that is the origin. You don't have to calculate that for me. And so that's going to be 0 to 1, top minus bottom on that curve. So A1. Top is the square root of x. Bottom is negative square root of x. And notice I get a double negative there. That's important. And then A2 starts at 1, goes to 4. Top minus bottom. The top is still the square root of x, but this time the bottom is the line y equal x minus 2. So minus parentheses, minus the quantity x minus 2. The parentheses are vital there because you have to subtract the entire expression that represents that bottom curve, or in this case, the bottom line. You have to subtract the whole thing. So parentheses vital. If I said set up only, there's the end of the setup, where you will very concretely showed me how you got those points of intersection, and then you show me the integrals. But now working it out, that's going to be 2 square root of x dx plus the integral from 1 to 4 square root of x minus x plus 2 dx. Just for reminder's sake, that's 2 times x to the 1/2 dx plus 1 to the 4th, x to the 1/2. Minus x plus 2 dx. Find the antiderivatives. Increase the exponent by 1. Multiply by the reciprocal of new exponent. Evaluated from 0 to 1. Increase the exponent by 1. Multiply by the reciprocal of new exponent. Increase the exponent by 1, multiply by the reciprocal new exponent, and the antiderivative is 2x, evaluated from 1 to 4, and now it's just arithmetic, and I will leave the arithmetic and everything, it's plugging in the 1 and the 0 and the 1 and the 4, and I will leave that all up to you. But the big point on this one that I wanted to note, to really emphasize, is it required 2 integrals because top and bottom switch. And so whenever you're integrating with respect to x, and when you're integrating with respect to x, it's top and bottom. So you've got to very carefully analyze the picture and ask yourselves, are there any changes in where top and bottom? And if top and bottom change, you need to have another integral. So when you're using x, think top and bottom, and if there are changes in top and bottom, that indicates another integral. And that's where we'll end this video.